Okay, so this is the PhET Molarity simulation, interactive simulation for solutions and concentrations. Now to get started, once you open up those from Google Classroom, you're going to have this document and you're going to have this PhET simulation. And we're going to split these so that we can have one on one side and one on the other. So I'm going to go ahead and pull this. I'm just going to click and drag this out. That'll pop out. And if I go all the way to the edge, see how it turned kind of gray? That tells you where that's going to land. Now over here, if I go to this minimize button, click it, those two arrows tell me where it's going to pop over. So I'm going to pop this over. And so now I have both on each side so that I can do both at the same time. Okay, so what this is showing is how solutions and concentration, the solute solution, how all that's connected. Okay. So it starts out, a solute is a substance that is dissolved in a solvent to create a solution. The concentration of solutes in a solution can be calculated using the following. Concentration and molarity, so that's how strong it is moles of solute, which is the stuff that you put in it, divided by the liters as the solution. So however much stuff you put in it divided by however much total you have when you're done gives you the concentration. Okay. So to use this, one thing that's pretty handy is if you hit tab, then it'll jump through. And if you hold down shift and tab, then it jumps back. So let's make the math easy. I'm going to drop that to 0.5, excuse me, bring this up to 0.5. So 0.5 divided by 0.5 is 1. Okay. So investigation question, how does doubling the moles of solute affect the concentration of the solution? Here's where you would put your prediction. You can print this paper out or you can type it or excuse me, you can print it out and handwrite it, or you can type it right here, or you can just follow along because you're not actually going to turn this in. This is for your improvement in personal learning. It's not something that I'm going to take for a grade. Okay. So here's where you would put your prediction, and I'm not going to spoil that for you. All right. So your procedure. We've got this open, and the values are on. If they're not on, you just check that box right there. Okay. We're going to set the solution volume to 0.25. So I'm going to hit tab, back tab. There we go. Bring this down to 0.25. Okay. And we're going to leave this one. This one says the value will be kept constant. This one we're going to leave alone. And this is the one we're going to manipulate. Okay, so this is going to be the, excuse me, the independent variable. This is the one that we're going to mess with. Okay, so we're going to set the solute amount to 0.05 and record the concentration on the data table. And the procedure, double the solute amount as shown on the data table and record the concentration each time. So we have moles of solute at 0.05 and the solution volume at 0.25. And we get a concentration of 0.2, so 0.2, all right? Now, we're going to increase the moles of solute. So I got to come back over here, hit tab, and I'm going to increase it. I'm going to double it. So double 0.05 is 0.1. And that gives me 0.4. So I got 0.4 here. Okay. Double of 0.1 is 0.2. That gives me 0.8. Okay. All right. Double the moles again. We got 0.4. That gives me 1.6. Double it one last time from 0.4 to 0.8. And that gives me 3.2. Okay. So how does doubling the moles of solute affect the concentration of the solution? Okay, so every time I doubled this, the moles of solute, it doubled the concentration of the solution. Okay, so doubling the moles of solute doubled the concentration. Okay, so these are directly proportional. Okay, so every time I doubled this, this got doubled. Okay, and in fact, you can see it if you watch the arrow as you manipulate this. Okay, it moves exactly the same. Okay, so they both jump up and down. If this goes down, the concentration goes down. If this goes up, the concentration goes up. Okay, so now part 2. What will happen to the concentration of a solution if the solvent and the solute are doubled at the same time? Okay, so if we do the solvent and solute, what's going to happen? Okay, and here again is where you would put your prediction. Procedure, we're going to open the molarity packet practice and set it to show values. Okay, still set there. I'm going to set the solution volume to 0.25. Okay, that one's good. Set the solute amount to 0.05. So you got to come all the way down here. And we're going to record the concentration. All right, so 0.2. All right. Now we're going to double the solute and solvent. Okay, so we're going to double these. So that one is going to go up, and that one's also going to go up. Okay, so that one doubled to 0.1, this one doubled to 0.5, and it's still 0.2. Okay, and now we'll go back over here. We're going to double this again, so 0.2. I'm going to bring this all the way up to 1, 0.2. Okay, so what happens whenever you increase the solvent and the solute at the same time? What happens to the concentration? Well, the concentration is going to be the same. Okay, and the reason why it's going to remain the same, why it's going to remain constant, is because solute divided by solvent gets you solution. So right here, this is marked as drink mix. So this is like Kool-Aid or lemonade. Okay, whenever you are making it, if you're going to double it, then you double the amount of water, but you also need to double the amount of mix. If you don't, then it's going to taste terrible. Okay. Now, something to point out here, we see the solution, the amount of solvent. Okay. As we drop it, concentration goes up. Okay. And let me do this way instead. Okay. All right. Now you notice as this one goes down, as the solution volume goes down, the concentration goes up. Okay. Okay. So they go in opposite directions. So these are that inversely proportional. So when one goes up, the other one goes down. Now, remember how that looks like a curve. Okay. So I'm going to start this at the bottom so it's a lot easier to see. Okay. That curve, each step at first is very steep. So each step down, it's almost like dropping in a roller coaster. And now it's starting to get less and less. Now it's at the bottom and it's just kind of flattened. Okay. So what we're seeing is that solute is directly proportional to concentration of solution. Ha. Those of you that have me in class know I can't spell. Okay, so solute is directly proportional to concentration of solution. Solvent is inversely so the solute, the stuff that you put in this case drink mix, drink powder, whatever, is directly proportional, and solvent is inversely proportional. All right, and so what you wind up getting with solute is you get that direct proportional graph, and with solvent you get the inversely proportional graph. I hope this helps. I hope it kind of helps things make sense a little bit, and I really hope you guys are learning from these videos, kind of enjoying these videos. And please give us feedback on the feedback form so that we know what we need to do to change things, help you out with these. And we hope to see you really, really soon. We really miss you guys.